Okay, here we are, example 60. And in this example, I want to do the same thing. I want to find the critical points of f of x equals x to the 1/3 times x minus 4, quantity x minus 4. Identify the open intervals in which f is increasing and decreasing, and find the function's local and absolute extreme values now. So now we're going for the local and absolute extreme values, and we're talking about the entire from x being on minus infinity to infinity. Okay, so all right, so here's my function. Notice I distributed x to the 1/3 first to make it easier to take the derivative. So f prime of x is 4/3 x to the 1/3 minus 4/3 x to the minus 2/3. Okay, so in that I have an x to the minus 2/3 common to each and a 4/3 common to each. I'm going to factor out x to the minus 2/3. I'm left with that times the quantity x minus 1. Right? X times x to the minus 2/3 gives me x to the 1/3. Minus 1 times x to the minus 2/3 gives me minus x to the minus 2/3. So that's correct. So notice that this is equal to 0 when x equals 1. And this is the same thing as x to the 2/3 in the denominator. So that equals 0 when x equals 0, which means that the derivative is undefined there. When the numerator equals 0, the derivative is 0. When the denominator is equal to 0, the derivative is undefined. Okay, so when the derivative is undefined, that's also a critical point. So what do I have? I have two different critical points, x equals 0 and x equals 1. The derivative is undefined at x equals 0, and it's 0 at x equals 1. So I'm checking on either side of my critical point. So I'm going to check f prime at minus 1 and see what I get. I get minus 8/3, which is negative. I'm going to write a bunch of little negative signs. I notice I didn't put it on my notes, but I would normally write a little down arrow here, reminding myself it's decreasing on that interval. And then between 0 and 1, see, the easiest thing to check is probably 1/2. So I'm going to check f prime at 1/2. After all the algebra, and I really don't care exactly what this number is, but I have a negative number divided by a positive number, so I know that that's negative. So then I'm still going to write a bunch of little negative signs, and I didn't write it, but again, I would write a little down arrow here, indicating I have a decreasing on that interval as well, decreasing function on that interval as well. And then for x greater than 1, I checked f prime of 2. So when I plug all that in, that's a positive number divided by a positive number, so that's also positive. So then I put a bunch of plus signs, and I should have put an up arrow here just to indicate I have an increasing function on that interval. So what's f of x? It's decreasing on minus infinity to 0. Notice I don't include 0 because there the function is undefined, so I can't say it's decreasing there. Not the function is undefined, the derivative is undefined. And then from 0 to 1 also. So minus infinity to 0 and also 0 to 1 or 0 to 1. F of x is increasing from 1 to infinity. Remember, these are always open intervals. So let's see, if I have a decreasing function forever from minus infinity on, and then at x equals 1 it starts to increase, that means I will never have an absolute maximum because it's going to be all the way up here at infinity, come down, down, down to here, and then increase again back up to infinity. So there's no absolute maximum. However, there is an absolute minimum at x equals 1. And if I want to find the exact value of that point, plug in x equals 1 into the function. I get 1 minus 4, which is minus 3. So actually, the absolute minimum value is minus 3, which occurs at x equals 1.